Last time we looked at solving quadratic trinomial equations that were equal to 0 and had a number in front of x squared that was a 1. Well, that's not going to be the case necessarily today all the time, and so that's our objective today, is can we factor and solve a quadratic equation which could have as many as 2 solutions with both of these conditions maybe not in play. So here we go. There's lots of different ways and tricks to factor trinomials, and this is just one way. Okay, if you find a different way that works for you, by all means use it. This is just a suggested way that a lot of my students over a number of years have been able to work with, and no matter what method you use, you can get really fast at this, but it takes a lot of practice and a really good number sense. So here we go. We're going to use this x method, we're going to call it. And what I've got to do is I've got to find 2 numbers that are going to multiply to 20. I'm going to put 20 up top here. 20 comes from the product of 2 and 10. And I have this middle term of 9 up here. I'm going to put that down below. So I'm going to find 2 numbers that multiply to 20 that add up to 9. So I'm going to jot down the factors of 20, 1 and 20, 2 and 10, and 4 and 5. Everything is positive in the problem, so I need 2 positive numbers to multiply to 20 to add up to 9. And my options, 4 and 5. This is just kind of a graphic organizer way to just kind of organize your thoughts in a way that hopefully makes sense to you. As you get good, you might not even need this process. So now I'm going to make 4 boxes like I did when I multiplied before. So the top box is going to have 2x squared in it. And that comes from the first term in the quadratic equation. The last box is going to have a positive 10 in it, which comes from the last term in the quadratic equation. Now I'm going to take my 4 and my 5, and it doesn't matter what order I put them in, but I'm going to put an x with both of them, because 4x plus 5x gives me my 9x, and I have all 3 parts of the quadratic equation there. So now I start on top, and I think, okay, what's the greatest common factor of 2x squared and 5x? Well, that's an x. Now, I have to think x times what gives me 2x squared, and that's 2x. I go to the top right and think, okay, I have an x, what times x makes 5x, and that's a positive 5. See, this x out front and this positive 5 are going to make this 5x in the box here. So now I have 4x down here. Well, I have 2x up top, and I'm going to need a positive 2 to go with it. Now, what I also see is I notice I need a 10 at the bottom here. And this plus 5 and this plus 2 multiplied together make 10. So I've got everything I need. And I've just found my factors, 2x plus 5 and x plus 2. So I'm going to jot those down. 2x plus 5 in parentheses times x plus 2. If I foiled those together or multiplied those, I would get the original quadratic equation. So I set both factors now equal to 0. And I solve. And the first one gives me negative 5 halves. And the second answer is negative 2. Those are my 2 solutions for this particular item. So if we take a look at this process, we can use it if we have the number in front of x squared that is something other than 1, much like the next problem. And let's go to example 2 at this time. The first thing we notice is it's equal to negative 4, and I've got to fix that right away. So I'm going to add 4 to both sides. So the equation I'm really going to be working with is 3x squared minus 13x plus 4 is equal to 0. So let me make my x, and then we'll box it up after that. So I'm going to multiply the 3 and the 4 together to make 12. And I've got this middle of negative 13. So I've got to find two numbers that multiply to 12. So 1 and 12, 2 and 6, 3 and 4 are combinations that add up to negative 13. Well, both numbers have to be negative. A negative times a negative is a positive, and two negatives could add up to a negative also. And my number sense tells me that negative 1 times negative 12 is positive 12, and negative 1 times negative 12 is negative 13. So now, my friends, I am ready to box it up. The top box is going to be my 3x squared. Comes from the first term. My last box is going to be this positive 4. And my other two boxes should add up to negative 13x. So negative 1x and negative 12x. The order of those, again, doesn't matter, but those two combined make this negative 13x. So I'm ready to roll. Take a look at the top row. What do they have in common? Well, 3x is going to make, let's do this in a different color, 3x is the greatest common factor in the top row. So 3x times what will make 3x squared? Well, x. Well, now how do I make negative 12x? Well, I've got this 3x out front, and I need to multiply it by a negative 4. Now, I go to the bottom, and I think, okay, I need a negative x. I have an x, so I'm going to need a negative 1. And does it check? Well, negative 4 times negative 1 is indeed positive 4, so my factors are x minus 4 and 3x minus 1. So x minus 4 and 3x minus 1. And I set both of those equal to 0 and get 4 and 1/3 for my two solutions. There's one problem I want you to try on the bottom here, so I'm going to pause the video and you try it based on these couple examples, and then I'll take you through the process one more time here momentarily. Okay, so I'm ready to go here. So we are equal to 0. And because we're equal to 0, we can go ahead and multiply our 3 and our negative 20 to get negative 60. And our middle is going to be negative 17. So I've got to come up with two numbers that multiply to negative 60 that add up to negative 17. And just like that, there's my list of numbers that could indeed work. And so let's take a look at my options here. So to get a negative 60, I need a positive and a negative number. And so which pair will give me a negative 60 but add up to negative 17? Well, that's going to be a 3 and a negative 20. And so let's put everything in the boxes. So here we go. Top box, 3x squared. And bottom box, negative 20. My two numbers I just came up with, my 3 with an x and a negative 20 with an x. And this gives me 3x squared, negative 17x, and a negative 20 when I put them all together. So what does the top row have in common? Hey, this isn't bad. Well, the top row has a 3 and an x in common. So I need the 3x squared, so I'm going to need an x above it. And over off to the right, I have a 3x, and I have a 3x out front, so that means I'm going to need a positive 1. Now, to get this negative 20x on the bottom here, I have this x on top, so I'm going to need a negative 20 to go with it. And now, does it check? Well, 1 times negative 20 does give us negative 20, so I've got everything that I need. And so my factors are indeed x plus 1 and 3x minus 20. So I'll jot those down, x plus 1 and 3x minus 20. Setting both of them equal to 0 gives me negative 1 and 20/3 for my two solutions. Now, this whole process, no matter what method you find to use, whether it's this one or something else, this yellow box I'm outlining, it all comes down to that. Can you find factors? And do you have a good enough number sense where you can put them together to solve by factoring a trinomial quadratic equation? It takes persistence. It can be done. You can do it.